Hi, I'm Kartik, and my nomination for Maths Idol 2013 is the French mathematician Benoit Mandelbrot. He was a bold, creative mathematician who went off in a different direction to other people, who liked to prove people wrong, and his willingness to challenge convention made him a revolutionary but at the same time a controversial figure in the past century.
He was born in the mid 1920s in Poland but escaped to France during the Second World War as a refugee. He went on to be picked up by some of France's top academic institutes and then did his masters at Caltech in the USA before returning to do his PhD at the University of Paris in the early 1950s. He ended up being picked up by the technology company IBM and their research lab, where they'd pulled in all of the smartest and most unpredictable people from all across the world, knowing that they'd do something brilliant for the company. And Mandelbrot did, because it was whilst he was in the USA and doing research for IBM that he effectively invented a whole new branch of maths called fractal geometry. Now, fractals are shapes that can be broken into smaller parts, where the smaller parts are echoes of the shape as a whole. Mandelbrot recognised that the real world isn't made up of straight lines, squares, and other shapes like that. Everything has an element of roughness and unpredictability about it. Fractals are everywhere in nature, the shape of a lightning bolt, the coastline of Britain, or even just the human heartbeat. The most famous fractal shape is a shape that was actually named after Mandelbrot himself, called the Mandelbrot set. It was created by using this, a very simple formula, and changing the value of c. If you iterate it 100, 1,000, or millions of times, like Mandelbrot did during using the powerful supercomputers at IBM, it creates this shape. And if you zoom into any one part of it, it becomes more and more and more complex. In theory, you could zoom in forever and it would still create unique shapes. Mandelbrot founded an area of maths which studied fractals, and because of his work, people are now able to use maths to find order and regularity in parts of nature that the world around us that we previously thought were completely irregular and just ignored. He was such a controversial figure because his work was so revolutionary that it forced academics in every field all across the world to change the way they did things significantly. It was worth it because fractal geometry describes the real world much more accurately than straight lines and polygons ever could. So it allows us to do much more. It allows us to, say, draw realistic natural objects like clouds and mountains on a computer screen, something which film producers use all the time to create fake backgrounds. It can be used in biology to study the evolution of ecosystems, or in economics to describe the volatility of stock prices. It's because of his work that we can accurately predict the weather, enlarge digital photographs, and even prevent heart attacks.
So it's really for two reasons that I think he should be voted Maths Idol 2013. Firstly, because of his work and how influential and groundbreaking it was, but also because of him as a person. He always wanted to push the limits and do something different to other people and prove people wrong. And I think that's something that should be admired. And it's for that reason that I think he should be voted Maths Idol 2013.